so this was a meetup we had in Dnipropetrovsk literally a couple days ago, and hopefully some of it might still be relevant to you guys. So a condensed version thereof. Quick preface, Java 8 has been in production since 2014. A lot of us have already migrated our JVMs to Java 8, as it should be, which also begs the question, given that the things that Java 8 brings to the table, is Scala still relevant? Obviously, since I'm here, the answer is an emphatic yes, it is very much still relevant, and I'm going to try to convince you, or if you're already convinced, I'm going to try to give you some ammunition if you're going to be having this debate in the future about why Scala is still preferable to Java in every sense of the word. So, a bit of a history. We're going to be covering just a little bit about the gaps between Java 8 and Scala, historically, and between Java and Scala historically and today. We're going to talk about how Java 8 reduces that gap to something worth discussing, and then we'll showcase. I'll probably pick just one or two of these to showcase differences between Scala and Java. So, historically, Scala has this huge feature set that Java does not, but really, in terms of Java 7 and below, you can reduce the discussion to 6 major kind of features that Scala offers over Java. And those are type inference, lambdas, traits, the collections library, DSLs, and implicits. Right? There's a whole bunch of others, like macros, like the whole ecosystem around Scala, but really these are kind of the 6 major selling points, I feel, for pre-Java 8 Java developers. Now Java 8 came out a couple of years ago, and it added lambdas, it added the streams API, which is sort of analogous to the collections library and about as powerful, and it added default method interfaces that could be argued remove the need for traits. It could be argued because it's flat out wrong, and I'm going to argue with that in a second. Just a quick refresher, there's these 6 features, but actually Scala offers you all of these things that you cannot get in Java. So everything from higher kind of types to declaration side variants to macros. All of these are really nice things. Let's focus on the big, the big wins. So why should you care, right? Why is Scala still preferable to Java? Let's talk about traits. Right, and let's talk about a canonical use case, and a very simple one, and a very easy to understand one for traits. I'm not going to be talking about linearization order, or composition, or initialization order. Screw that. Let's talk about logging. So you have this Java class, written in Java 7, Java 8, looks about the same. You have your SLF4J imports, you have your class of logs that defines a private logger, you have a very stupid method that normalizes names. It doesn't really do anything, it's just an example. Artificial wanted that. And it writes some stuff to the logs. And unfortunately, there are 2 very, 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 problematic things with this bit of code. The first is, there's a heck of a lot of boilerplate. Right, so if you're writing server code and you're using logging, and a lot of you are writing server code, and by definition you do a lot of logging. That means that pretty much every class in your however big server code base, could be 100,000 lines of code, could be 1,000 classes, could be 10,000 classes. For every single class you have to do this. You have to do these imports, and you have to define a static logger, which obviously is annoying. The second and arguably much more important difference, or problem, if you will, is that you have eager evaluation of your logging messages. So if you're, say, receiving an object in JSON format and you're just dumping it to your log in debug level, which is something a lot of us do for for debugging reasons, for a whole host of reasons, just doing that serialization, deserialization, putting strings together, it becomes expensive, right? Especially if it's in a hot path in your application. It's just very, very costly. You don't want to do that if you don't have to. So in effect, this is actually kind of a lie, because in reality, production code would have something like if log.isDebug enabled, only then will you log the debug message that you construct on the fly, right? And that kind of sucks, right? You have those ifs strewn around your code base, you have indentations, everything just becomes big for no reason at all. So the problem, with Java 8, you can get a little bit closer to what Scala offers you, but ideally what you would want to have is something like this. public class logging samples, implements logging, it removes the need for log dot, it removes a lot of boilerplate, and if you could, you would want to have it lazily evaluated, so that only when the bug logging is actually enabled, you get to see your log messages, and you pay the cost for stringing all the strings together. Unfortunately, you can't really do that. So Java interfaces added in Java 8 something called default method interfaces, which allows you to define a method in an interface and give it a default implementation. So at first glance, this might appear to be a partially implemented interface, which is kind of the way most people perceive Scala traits, right? But in fact, not really, because you cannot carry state, and you need a logger instance, right? So you have your public interface logging, and you end up having to define a getter for the log instance just to be able to provide a logger to the internal implementation that is defined within the interface, right? And once you do that, you've actually lost most of the benefits because you still have the boilerplate, right? You still have to implement a getter that goes to the log manager and brings in a log and feeds it into the rest of the infrastructure, which kind of defeats the purpose. So the other problem is that Java interfaces only provide public interfaces. Right? You cannot have private members, protected members, you cannot have state, as we mentioned before. So all these debug and warn and info, et cetera, helper functions are visible outside of your class. They're visible to the users of that class, which obviously is a bad idea. Right? So in practice, you cannot have your logger trait in Java 8, no matter how much you want. One thing that Java 8 does do is it gives you some facilities for lazy evaluation. So with lambdas, you can use this supplier functional interface to kind of mimic lazy evaluation. Not kind of, right? It is basically lazily evaluated, except the syntax and the usage side is a bit annoying. You have to have these open and close parentheses and the arrow. But it's not too bad. This is something that you can sort of live with. Obviously, the other alternative is to use formatting strings, which actually has the interesting side effect of if you're logging with formatting strings, and certainly if you're doing the bug logging, and then what typically happens is something breaks, you enable logs, then and only then do you actually find out that you've forgotten a placeholder in your logging code in your format string, and then actually once you enable the bug log, your server will throw exceptions on every single request because you screwed up the logging, and no one tests logging, right? You don't have unit tests for your logs. Why would you? It's a waste of time, right? So do not use format strings. They're inherently unsafe and inherently stupid. So this sort of improves matters in Java 8, but that is literally the best you can do. With Scala, you have traits, and traits, a lot of people think about them as partially implemented interfaces, and that's fine. You don't have to go all out and conserve them in modules and figure out the linearization order and all that stuff. But it does allow you to have state. A trait has life cycle, right? It has a constructor body. You can initialize fields. You can do all that stuff. It supports visibility modifiers. It's basically a form of multiple inheritance that's actually mostly type safe, right? I'm sure some of the smarter people in the audience, I'm looking at you, Dimitri, can find ways to break the type system soundness with traits. In effect, in production day-to-day, I have not run into a situation where I really badly screwed up my code base because of initialization order. So a logging trait would look like this. Trait logging creates a private value of logger, and then it offers these warn or debug or whatever methods that are protected. And the message parameter is by name. So it looks very, very simple, but it actually gets lazily evaluated, which is exactly what we want. So this is a very straightforward, kind of everyday thing that you would want to have that you cannot implement in Java 8. So, it is what it is. Right, questions around this? No, okay, this is pretty straightforward stuff. Pattern matching I'm not going to show because I'm assuming that people in the Scala conference actually know their stuff. So blah 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 blah. Implicit is actually a very very nice property of Scala. It can be a little daunting for people first coming from the Java world, but you know, let's not go into too much, haywire ways of using implicits. Instead, let's talk about something that is very common in the Java world, which is serialization. Right, so serialization basically is a three-step process. You have the main class, and you do some sort of reflective process on it to figure out what are the components. Right, you have your domain class, you need to figure out what are the properties, right, and what are the types of the properties. So there's a reflection process going on. The second step is you dispatch, right? You iterate over your components and you dispatch to the right type serialization based on type. So if you have a member that is a first name that is a string, you dispatch to a string serializer. If it's some other domain object that you've already reflected on, you dispatch to that. There's this recursive process of dispatch. You aggregate the results and eventually, profit, right? You're done with the serialization. Thing is, in Java, you really don't have too many options. Basically, the go-to library in Java is Jackson, which I assume most of you have used in the past, and a lot of you probably still do. It works. It's fast enough. It's pretty performant. It does a lot of aggressive caching to reduce the runtime reflection overhead. It's okay. But it's ugly. Right? So it's ugly for a variety of reasons. First of all, runtime reflection is very hard to predict. So a lot of things, like you're working in a statically typed language. That means that you do not want to be able to compile code that will break at runtime. And the whole point of having a statically compiled language is to reduce the surface of errors that you can have at runtime that you would have been able to detect at compile time. But any serialization mechanism based on runtime reflection is inherently risky, right? It's almost broken. It's very hard to predict. It loses data because of, among other things, erasure. So if you've tried serializing to serializing options or maps with Jackson, you need to do some hackery around it and set up the proper modules in your object mapper and other annoying things. And it might be pluggable via modules, but it's really easy to forget. You didn't set up your object mapper right, you get an exception at runtime, which sucks. Right, so you end up either accepting the possibility of exceptions at runtime, which is not what you want to do, or writing tests for code that is essentially very, very simple and should not have compiled in the first place if it was not correct. And that kind of sucks. So with Scala, you use implicits, right? You use type classes. You use your serialization type class, serializer type class, and you let the compiler figure out the correct wiring of serializers. And the nice, a nice property of that is not only that you can do the reflection at compile time. So if you've used play.json, for instance, you've probably used the formats macro or the writes or the reads macros. All these things is essentially the same reflective process that Jackson will do at runtime, except at compile time. They look at your case classes, they figure out the structure, and then they produce the appropriate description for subsequent serialization logic. And the wiring just happens by the compiler. So the dispatch, this serialization dispatch that says I have this address class, I need to dispatch to an address serialization, happens via implicit search. And that means that at compile time, if your serialization framework does not know how to handle a particular type, it immediately breaks during compilation. It just tells you I cannot find an implicit serializer of whatever particular type you try to use and have not defined, and you do not have to write tests or do smoke tests for your serialization code. Right? You get compile time safety. It also has the added benefit of being faster. Right, because you do not do compile time runtime reflection, and you do not have to do code generation to avoid reflective access to your objects. So it saves you space on not the permgen anymore, but the meta space. Right? It has all these benefits because it all happens at compile time, and it's safer. Right? So this is the preferred solution. You literally, sorry, I just basically said all this thing. This is the preferred solution. Right? If you're writing in Scala, you can do this. If you're writing in Java, you cannot do this. Or you have to add external tools to your build pipeline just to get the same benefits, at compile time instead of at runtime. How is that better? Better performance, better reliability, which is kind of what we want, right? Write less code, write simpler code, get more safety out of your compiler, get better runtime performance, big win. So all of the Scala serialization, typically JSON, because that's what everyone uses these days, that's what all cool kids who hate XML do, right? All serialization frameworks, including PlayJSON, including SprayJSON, including LiftJSON back in the day, JSON for S, work based off of the same pattern with very subtle implementation differences. They're all the same. And I guess that's enough for now. So thank you very much. If there are any questions. Any questions? Oh, here's one.
So in your example, when you were trying to mimic the logging example from Java, actually, because of the way how it creates a compile, there is one difference which is left. In Scala, you have a logger field in every instance of the class. In Java, you had it static.
Yes.
So it means that in Scala, your classes will actually have a bigger memory footprint.
True.
So do you know a way around this?
So did everyone get that, or should I repeat the question? Yeah, seems good. Right. So in Java you can do it statically. In Scala, because it's a logging trait, you do it, not as a static member, but as an actual instance member. Is there a way around that? Certainly there are ways. You could have that logging. You could have two separate traits that compose into a logging thing. One is on the companion object, say, and one is on the actual instance trait. You can certainly do that with sort of external tools, macro annotations, a whole bunch of possibilities. Personally, I hate magic, and as far as I'm concerned, macro annotations are kind of magic. Not only that, but they also add a compile time dependency and a compiler plugin in your downstream dependencies, which is something that is, Accord doesn't do that, by the way, the library that I mentioned has 0 dependencies. And I don't think it's worth it. So really, if you have so many allocations of a specific type of class where this matters to you in terms of memory footprint or even runtime performance footprint, you're probably doing something wrong, or you can just, not use the logging trait in that specific context. Ways around it, yes. Should you use them? Probably not. I mean, in effect, it's not really a big deal for almost all use cases.
Would you have liked it if you had a way to create static fields and static methods in Scala?
Would I have liked it if I had a way to create static fields and static methods? Well, I have a way. It's called the companion object, right? But if I had a way to do that sort of automatically through a trait on the instance class, I guess I would have to actually see the mechanism to figure out if I like it or not, because I can't really envision something that does that and is still clean and sensible. But surely, someone might come up with some way of doing that. If there was, sure.
You can influence, we can ask for it.
There is.
There is, okay. I'd love to see that afterwards.
Not in there, you can add static annotation, which, by the fact how mixing computation works, happen to work this way in Ritz.
Oh, okay, interesting. Well, I'm looking forward to Dottie for a variety of reasons. This would probably be one of the more minor ones, but I'm still very much looking forward to it. Okay, any other questions or complaints? You want to kill me? Because that's fine. Okay, thank you. Who's next? So we have here Daniel Coldham, who also happens to work for Wix, and he's talking about event sourcing. Hooray!
Yes, sir. Next.